Welcome to Algebra with Miss Swartz. Today, continuing with our data unit, we're going to look at box and whisker plots. We're actually going to make some, and we're going to try to interpret some of them as well. You may have heard of them, you may not have made them, it might have been a while, kind of depends, but we'll make sure we cover everything to make sure you understand box and whisker plots. Okay, so how can we use a box and whisker plot to describe a data set? Remember, the idea of data unit generally is trying to find ways that help us describe a set of numbers without listing all the numbers. So that's what our box and whisker plot's going to do as well. So here's our big slide. This would probably be important to write down. Maybe you can try to summarize some of it, but there are a lot of important pieces in here. Okay. A box and whisker plot shows the variability of data along a number line. So you'll see the number line down here, and we'll be creating a number line anytime we make a box and whisker plot. Okay, we use 5 numbers that make up the 5-number summary when we're working with box and whisker plots. So every time we have to make one, we need these 5 numbers. So here are the 5 numbers. The least value, pretty easy to spot. The greatest value, also pretty easy to spot. Okay, and then the quartiles of the data, which we're going to talk about. Okay, quartiles divide the data set into 4 equal parts. So you'll see here, here's part 1. Okay, this would be part 2. This is part 3, and this is part 4. Okay, and you'll see kind of this broken up. So the median is the second quartile. So we have to be able to find the median, which, again, not difficult. And that divides the data into 2 halves. So you'll see the median here. We have this half and this half. Well, remember, we're dividing into 4 parts, so we need also the median of the lower half. Okay, that's going to be our quartile 1. And then the median of the upper half. So we're using the median a lot, and that separates us into these 4 parts. Why is it called a box and whisker? Well, you see, you have whiskers on the ends and a box in the middle. The median runs down the middle of that box. Okay, so every time we're looking for a box and whisker, the first thing we'll do is find that 5-number summary. That's very important when it comes to box and whisker. So as you can see, then we go ahead and plot the 5 points. So really the steps, okay, so we can break this down a little more simply. Step 1, find greatest and least value. Step 2, find the median. And then from there, you're able to find quartile 1 and quartile 3. Okay, once you've done that, step 4, you're going to plot the points on the number line. Okay, so we have least value, quartile 1, quartile 2, quartile 3, and the greatest value. Plot all 5 points, and then we're going to draw in box and whiskers. So kind of 5 steps. Obviously these kind of all fall into the same idea here. Okay, so you could narrow it down to find the 5-number summary, plot them on a number line, draw the box and whiskers. So let's go ahead and try one. Okay, it says make a box and whisker plot that represents the ages of the members of a backpacking expedition in the mountains. Okay, so the first thing we have to do is find the 5-number summary. So I always just list them because it's easy. So I always start with greatest and least. But the first thing that I like to do before I start any of that is make sure I have this listed in numerical order, because I'm going to use that when it comes to the median. So 18 is my smallest. Then it would go 22. And I have 2 of those. 24. 3 25s. 27, 28, and 3 30s. Okay, so my first number is my least number, that would be 18. My greatest number is 30. Okay, then I'm going to look for my median, so I'm going to count to the middle. So I want to make sure that I have all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. So I'm going to work my way to the middle. I have an even number, so I'm going to end up with 2. So I'm going to have to divide, or find the average of the 2. But if the 2 are both 25, the average of that's going to be 25. So we're good to go. Okay, now, this is important. When we have an even number, whenever we find our median in the middle there, technically, this 25 is included in the lower half of the data, and this 25 is included in the upper half of the data. Normally, the median is not included in either, but if we have the middle ground, we have to include those both on both sides. So now, what I want to find, okay, this is my median, this is my greatest, that's my least. I want to find quartile 1. Well, quartile 1 is the median of the lower half of the data. I'm going to do this in a different color for you so you can see this. So this is my lower half of the data right here, and I'm going to find the median there. So I'm going to move in here, and I actually am in the middle of these two numbers. So if I add those and divide by 2, the middle of those two would be 23. So my quartile 1 is at 23. Now, I'm going to do the same for quartile 3. That's the upper set of my data, so that would be right here. Okay, and I'm going to work my way in, and I end up here. The middle of that is going to be 29. Now, if you need to add those and divide by 2, do it, but I just can see that that's what it's going to be. So now I have my 5-number summary. Now I'm going to make a number line. Okay, whenever I'm working with my number line, I want to make sure that I can fit all my numbers on here. So sometimes I go by 2s, sometimes I go by 3s, but I just need to make sure that I have all the numbers. So we'll start with, maybe I'll go by 2s going from 16. And obviously I don't need to go that far, but I was just filling up the graph. Okay, so I'm going to plot my points. My first, my least is right here at 18. My greatest is at 30. Okay, my median is at 25, so that's going to be right here between 24 and 26. My quartile 1 is at 23. And my quartile 2, or 3 is at 29. So here are my points. Now I just have to draw in the box and whiskers. So here's the important part to know. Your box goes from quartile 1 at 23 to quartile 3 at 29. Okay, and our median, we draw a line down the middle. And our whiskers extend from the least value to quartile 1 and the greatest value to quartile 3. So that would be my box and whisker plot. Good. Okay, so you can label these if you'd like. You don't have to if you have them listed over off to the side, but sometimes it's nice to see what they actually represent because it may be difficult to read if you don't have it close enough. But those are our numbers. So what does the box and whisker plot do? It shows us how spread out our data is. So if we didn't know what the numbers were, we can see our data goes from 18 to 30. Easily we can find the range. Okay, we can see where most of our data is located. It's within this box. Okay, from somewhere from 23 to 29, that's where most of our data is located. And if you look, that is where a majority of our data falls from those two numbers. All right, so I want you to go ahead and try this one. Okay, a basketball player scores these points during a tournament. Make a box and whisker plot that represents the data. So go ahead and try that one on your own. You need to find the 5-number summary. Make a number line, and then draw your box and whisker plot. Okay. All right, the last thing we want to be able to do is interpret the data that when we're given a box and whisker plot. So the first question, A, says find and interpret the range. Okay, well look at your whisker plot. You know this is the greatest, this is the least. Okay, so if we're finding the range, we know we're going to take the greatest minus the least. So 300 minus 160 would give us 140. That's our range. Okay, so if we're interpreting the range, read what we're talking about here. It says, the box and whisker plot represents the lengths in seconds of the songs played by a rock band at a concert. So they last, okay, from 160 seconds to 300 seconds. So we have a range, or the songs a wide range of lengths is pretty much what we're seeing here. Okay, so that's what it means by kind of interpret. Right? Then it says describe the distribution of the data. So to talk about this, I want you to go to your journal and look at page 337. Okay? The distribution of the data is talked about there. It says shapes of box and whisker plots. Okay? So it talks about being skewed left, symmetric, or skewed right. Okay, so obviously skewed left, most of the left whisker is longer than the right whisker, and most of the data are on the right side of the plot. Okay, that's what it says on page 337. Symmetric, the whiskers are about the same length, and the median is in the middle of the plot. And then skewed right, the right whisker is longer than the left, and most of the data is on the left side of the plot. So here, if we look at this, we can see that it's skewed left. So that means most of the songs, if you think about it, in the situation, are longer than 220 seconds. That's kind of what you could think, okay, because it's skewed this way. Most of the data is on the right side of the plot, right in here. Okay. The last question says, find and interpret the interquartile range of the data. So this is an important word, okay? We've talked about the range, that's the range of the entire piece of the data, but the interquartile range is the range from quartile 1 to quartile 3. So if we look at this, okay, quartile 3 is at 280, and we're going to subtract quartile 1, which is at 220. If we subtract those, we get 60. So that's our interquartile range right here. Okay, if we interpret that, we know that most of our data falls within 60 seconds of each other. That's kind of our interpretation. Okay. And then there's one question you can't see down here that you'll kind of talk about maybe on a couple of the problems in your homework. It says, is the data more spread out below quartile 1 or above quartile 3? Okay, so if we're talking about more spread out, if the whisker is longer below the quartile 1, that means it's more spread out. Okay, meaning the longer the whisker, the more spread out you are. Here, our numbers are really condensed. They're closer together. So in this case, it's more spread out below quartile 1. So that goes back into skewed left or skewed right. Okay. If you have a longer whisker, that means it's more spread out. All right. So here's your homework. That was a little bit longer, but you guys will work through it. It's in the journal. It's just 4 problems. You have to do a couple box and whiskers. All right. Have a great day.